Let's read through this. It says, a perpetuity is an annuity that provides an endless stream of cash payments. That is, a perpetuity is an annuity in which the periodic payments begin on a fixed date and continue on forever. Now, the present value of a perpetuity is the value right now in terms of the total future cash flow that is defined as the improper integral. All right, so the present value, that's what this annuity is worth right now. And it's defined this way, where P, that represents the amount of each payment in dollars. R is the interest rate compounded continuously. There's the R. And T is the time in years from the start of the payments. So here's what we're supposed to do. Two things. Demonstrate on your own by evaluating this integral here that the present value is just capital P over R. All right, let's see what we can do. Let's evaluate this. So we're going to look at this. What we want to do is find the value of P times the integral 0 to infinity of e to the negative RT dt. Well, this is an improper integral, so I'm going to write this as the limit as b goes to infinity of P times the integral 0 to b of e to the negative RT dt. Let's keep our limit on there. This will be the limit as b goes to infinity of P times. Now, what do we get here? It's an exponential, so we get the function itself, e to the negative RT, divided by that negative r, right? Now, be careful. T is the variable, so r is the coefficient. So we just divide by the negative r, and we are going from 0 to b. So we will get, let's keep our limit on here, limit as b goes to infinity of P times, all right, put in the upper limit. We'll get negative e to the negative r times b over negative r minus the lower limit, e to the negative r times 0 over negative r. Got a lot of negatives here. Here's a negative, 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 negative. Let's make those positive so it's just a little bit easier to see. We'll get the limit as b goes to infinity of P times, okay, e to the negative rb over r plus, okay, what is this? Look what we have here. 0 times anything is 0. E to the 0 is a 1. So I'm just going to write this as 1 over r. Right, that negative negative gave us that positive. Now, this term here is an exponential decay function. Right, e to the negative rb, that's an exponential decay. As b gets bigger and bigger, right, b is going to infinity. As b gets bigger and bigger, that whole thing declines, decreases to 0. So this whole term is tending towards 0. This term over here has no b's in it. So what we're going to get here is when we take the limit, we get P, let's use the same color here. So we're going to get P times 1 over r. That's just P over r. And that's what we're asked to prove. Now, what about this part B? In part B, we're said that the present value of a perpetuity pays $30,000 annually beginning now. Assume an interest rate of 4%, compounded continuously. All right, find the present value. Well, the present value is given by this integral. But we just simplified that integral to P over R. Now, in this case, P is equal to 30,000, right? That's how much it's going to pay. R is equal to 4%. So P over R is 30,000 divided by 0.04. And that turns out to be $750,000 is what this annuity will pay out.